There we are. Hi, Javier. Welcome.
Hi,
Welcome to the
Dan.
show.
Hey, good to see you, Javier.
Yeah, thank you for having me here.
You're always welcome, Javier. So for people who don't, so for everyone who's joining and watching, Javier used to be part of the developer relations team at AWS, so we know him.
Here.
Yeah,
Just to be until not too long ago. Yes,
exactly. Yeah. So Javier, for those people who don't know you, introduce yourself, please.
Yeah, so I'm a developer advocate. I work at QuestDB. It's an open source time series database. We are going to be speaking about that today. And yeah, I used to work at AWS. I was specialized on data and analytics, so it's no surprise I'm working now with open source company. And yeah, I've been always around open source tools for processing data, managed on AWS or otherwise. So yeah, super happy to be here.
Cool. And obviously, before you tell me what and tell everyone what you're going to be showing, there is a very important thing we've got to do, right? And for regular people who watch the show, we have this feature. This is the most important part of the show, right? Where we understand whether we can be friends with you or not. Okay. So, do you like? So this is the board of the Tech Pizza and Pineapple relationship board. On this side here, we have the lovely people who love pineapple on pizza. And on here, we have those people we're still yet trying to educate. And then we have someone, Mathieu, you in the middle, who apparently is not fussy with what they eat, and they're in the middle. So Javier, which camp? Let me get you. Which camp are you? Are you in the good camp? Or are you in the not so good camp?
Actually, I never order pizza with pineapple, but if someone else is ordering, then I eat everything. So that's kind of the thing. So usually at meetups, if there is
that sounds a middle, Rick.
Pizza, I go for that.
Oh, so you're in the middle as well.
No. I like it. It's just
you like it? Yes. Yeah. Oh, very diplomatic. I think you might have come up with the most diplomatic answer to that question.
Hold on a second. But Javier, you've never ordered pineapple and pizza.
No.
That once you cross that line of ordering a dish.
I enjoy other pizzas better, so I order other things. But it's not that I dislike the one with pineapple. It's just I prefer others. But I also like it. It's just not my favorite.
Yeah.
But yeah, I'm not against that, and actually I enjoy it quite a bit. But looking at pizza is there are so many options. So
yeah. I think that what I find now is we're being marginalised. Us pineapple or pizza people are being marginalised. It's harder to find it in restaurants, right? So I feel like we're being persecuted a little bit. But anyway, we're digressing. Javier, what are you going to be showing us today?
Well, if you want, I'm going to be showing what QuestDB is about. Showing a little bit how you can start with it, and some of the main things that are probably different that what you can find in a traditional database.
Cool. Let's bring your screen on then, and as you're showing Derek and me, we'll be asking you questions. People who are dialed in, we have Javier Ramirez from QuestDB who's going to be showing us about all things time series, not time stream, but time series. I got that one wrong at first, so apologies. If you've got any questions, please use the chat, and we'll feed them to Javier along with his pineapple and pizza as we go along.
But don't ask him to order it.
No.
Yeah, exactly. I mean, I can order that. It's just I never do it. so yeah, if you want. So QuestDB, first of all, is an Apache 2.0 licensed database. So that means you can use it absolutely everywhere, no restriction whatsoever. I believe the Apache 2 license says something like, do anything you want with the product. Just don't take me to trial. Don't judge me. But other than that, it's do everything you want with the license. That's the summary of that. And it's a proper open source project. It's we at QuestDB as a company, we are about 20 people in the team. Not all of them contributing to the core, because we also have of course people for doing all the things. But actually we have over 100 contributors. So
nice.
it's a proper open source. We have nice community. Actually, this past month with Hacktoberfest, it's been super interesting. We had people from the community contributing for the first time and sending patches to add functions trim a string in the right or the left, which is something that we didn't have. So we saw a lot of contributions for those kind of things. So usually in every release, we have a few contributions coming from outside the company. But past month with Hacktoberfest, it was crazy. And we saw actually a lot of new people contributing, which was super nice. So it's open source, and we are a database, but we are not a generic database. We are a database specialized on time series, which means is if you have data in which the time dimension is important, it might be because data is moving very fast, or it might be because you need to do a lot of queries, filtering by time, aggregating by time, joining different data sets by approximate time. So when time is important for the queries you are running or for the ingestion, a time series database might be interesting. You mentioned, for example, Ricardo, TimeString, which is like a non-open source time series database offered by Amazon. So, that's kind of the thing we do. So we are very fast.
Yeah.
We like to believe we are the fastest time series database. Some benchmarks say we are, some benchmarks say we are not. Benchmarks is a lie. But in any case, we are quite fast. And it is how it is.
Yeah.
So we are quite fast.
I was going to ask actually, because like you said, there are other time series databases out there. How would you differentiate QuestDB from others out there? What do you say is your secret sauce?
Yeah. So one thing is performance. With a smaller machine, we can ingest a lot of data. I don't know. With a 4 CPUs machine, we can go over 1.5 million records per second, for example, ingestion. Wow. At the same time, while we are querying data, not only ingesting, but running queries on top of that. So performance is one, but the other is like the developer experience. We made the decision to use SQL for querying on QuestDB. Sometimes series databases support SQL for querying the database, but some other time series databases, they have their own language. So, you have to learn a new thing, which might or might not be intuitive. So we support SQL, we have joins, we have a lot of extensions for dealing with time series. So we try to really focus on developer experience and making working with time, if not enjoyable, at least human. You know how it is when you are working with time, you have to add to days or subtract or working with time zones. So we try to remove some of the pain out of that. So that would be the main differentiator, and that we are open source.
I think you're doing well there, because I've tried it, okay, and I've tried some of the other time series days. I definitely think that it is definitely easier to get started with QuestDB than I have had with some of the others, right? So I think you're definitely doing a good job on the developer experience.
Yeah, thank you. And that, it's a trade-off. Like sometimes it's like, oh, maybe we are not adding some feature because it's going to make it like more complex, or it's going to. So we are really conscious of trying to make it like more friendly and easy to use. So that would be the main thing. But in any case, there are other nice open source time series database out there. So try them all and use the one you prefer. That in the end there is room for many different things, and that's also the beauty of open source. Easy to try, easy to choose the one you prefer.
Sounds good.
Cool. So that's like so in a nutshell, that's basically it. But maybe it's easier if I show you what we can do in QuestDB. Just before I go there, if you like QuestDB, you want to give it a try, you have there, of course, the URL. But also, if you scroll down in the homepage, you will find the link to our Slack. So if you want to join the Slack and join the community, of course, pitch in and just ask anything you need there. So installing QuestDB, hopefully it's simple. You have several options. If you're on Mac, you can use Homebrew. If you are like any other in Windows or in Linux, we have binaries. QuestDB itself is built in Java. So you have also, you have Java. You can just download QuestDB and run it with Java, but we offer binaries. But for the demo, I'm going to be using just Docker, which probably is the easiest way to start in a consistent way. So I have an EC2 machine. I'm not running this on localhost. So I have an EC2 machine, and I want to just Docker run the latest version of QuestDB, opening a bunch of ports. So one port is for the web interface. The other one is for ingesting and streaming data. Another one is for Postgres interface. We speak the Postgres protocol. So, you can send your queries to QuestDB using a Postgres-compatible library. And this one is for monitoring QuestDB itself. So basically, I'm just starting with Docker, And out of the box, we get, let me see what I have, the browser. So out of the box, you get, here it is, a web interface where you can run your queries on QuestDB. By the way, everything I'm doing today, it's available on a link that I believe you're going to be publishing. So if you want to follow what I'm doing, it's everything on this quick start. So everything we are covering is going to be there. So when I started Docker without any persistence, without any volume. So my database is right now empty because I just started a new QuestDB. I don't have any tables. I don't have anything. So a quick way of ingesting data might be just loading some CSV data that you might have. So you can do that directly from the web interface. We also have a REST API, so you could also use the REST API just to ingest the data. But in this case, I'm going to ingest a very small data set just for testing things. So it's just not even 1,000 rows. So yeah, it was imported very fast. If your data set is bigger, it can take a bit longer. We have a blog post, quite fun if you enjoy these kind of things about optimization. So we have a blog post in which we ingest a 75 gigabyte CSV file and unsorted CSV, and we ingest about 300,000 rows per second. So in this case, it was super fast because it's very small, but actually you can ingest even large data sets in a good way. So after I ingest the data, I can see here I have a table. So you can just know you can click around on the interface. You can see here this table has a few columns, a few things. So this just represents some taxi rides in the city of New York, which is a very common data set. But yes, you get the idea. So when you ingest the CSV, this one, everybody's using this one. But that's cool. So
those poor taxis, right? They get so analyzed. I want imagine if you're a taxi driver, you're thinking, who in the world is analyzing our data today?
So some people on Twitch.
Yeah, I didn't like the name of the table. So you can do simple stuff if you are used to Postgres, those kind of things they work. But this is just with some extension that I will show you now. But this is just SQL. You don't have to to worry much when you are exploring a data set. So simple stuff, not too complex. So before I move on to streaming data, what I would like to do is I want to show you more interesting queries. So on this data set, in this demo data set, I have just very small data. But something we can do, we can go to the live demo. At QuestDB, we have a live demo, which is accessible by everyone. And we have a few data sets here. One of them is actually the trips data set. But in this case, it's a bit bigger. In this case, the trips data set, maybe I can make this a bit, So in this case, the data set is 1.6 billion rows, which is not too bad.
That all?
So this is we can have fun with this. So we can do things like, okay, tell me the average of one of these, for example, the fair amount. So give me the average of the fair amount for 1.6 billion records. So we are going to have to run a full scan here. We don't use indexes at QuestDB.
The show, I don't know if we told you, the show's only an hour.
So what?
The show only lasts an hour. So this query, how long is it going to take?
How long do you think it will take? 1.6 billion records.
Oh, about an hour?
5 minutes. 5 minutes.
I don't know. Let's see. You have an hour to spare. Oh man, it was actually quite slow. It was almost
500 milliseconds.
Half a second.
Really?
Yeah. But I know. Sorry about that. It's quite slow.
Wow.
But there is a motive for that. There is a reason why this is so slow. It's because we are a time series database. So everything we do in QuestDB is optimized for working with queries in which time it's important. It's part of the query. In this case, I don't have any filters. I don't have anything. We are doing a full scan. So of course it's slow. Of course it takes half a second. But if we start adding filters, okay, so where the date time is in, for example, 2018, things will be faster. Oh, this is better. 60 milliseconds. It's still slow.
Wow.
It's still slow, but now we are only going to the partitions, like for this particular year. It's only 100 million records, so it's nothing like but that's the thing. It's getting better. And if I go to 1 month, I don't know. If I go to, for example, June, that's getting better. That's already 30 milliseconds.
Wow, that is incredible.
Yeah. And by the way, we have this syntax in which you can do things like, I don't know, go to a specific day, to my birthday, for example, or go to a specific hour within the day, and you can go down to microseconds. So these things that
that's cool.
It's convenient. In other, if you don't have this kind of syntax for time ranges, maybe you have to start extracting whatever, the day and the second and the minute. So we have these small things. So that's the first thing. So about performance, this is what you get. This is a public machine. You can just test here, and actually we give you a lot of queries here that you can try directly. So you can play with that. It's easy to play with. So before I move to streaming, I want to show you something that I believe is interesting, because the speed is only a side of the torrent. The other side is doing interesting queries. So we have this data set, the trace data set. This one is live. It's not a batch data set. It's actually, we are calling the Coinbase API to track we are tracking the exchange of cryptocurrency between Ethereum and Bitcoin and USD. So we are calling every second or so, we are getting new data. Every time I run here, you can see I'm getting more data, for every second. So, and this is what it looks like. It's quite simple.
People are still trading crypto. Amazing.
Yeah. So this is quite simple stuff. Actually, we have a lot of traction with crypto. The project started in high frequency trading, like in the real banking world. But actually on crypto, we see a lot of traction with QuestDB, because you need to keep track of things that move fast. Yeah, that's one of the use cases, of course, apart from industrial, IoT, all those things. But actually in crypto, we have a lot of users. So this is
Javier, can I ask a question? So it's very, very fast. Okay. So what is QuestDB written in? Is it written in a modern language like Rust, or is it in, what's it written in?
Yeah, it's interesting. You asked that. It's written in Java, because the project started 8 years ago. So 8 years ago, our CTO was working for a bank, had to do some trading stuff, couldn't find anything that was simple to use and performant enough. So he started doing this in Java. 3 years later, he actually open sourced it. So, but it's Java, but it's not your regular Java. It's we are about performance. So basically, we avoid garbage collection. So we use manual memory management. So we want some parts of the application are built in C for C++ for performance, and we do direct memory mapping, so we don't have to convert data between Java and C. We share the same memory between the two processes, so we can speed quite a bit.
That's cool.
And since Java is Java is quite slow when the garbage collector is kicking in, and also in Java you have boxing and boxing, converting types all the time. Something we've done is we created our own classes for many things, like for strings. The logger, it's our own logger, so it's a few nanoseconds faster on each call that using log4j, for example. We have our own libraries for network input-output. So basically in QuestDB, we have 0 external dependencies. It's Java, like the syntax is Java, but actually it's not using any Java libraries. It's not doing it's kind of interesting. Yeah.
Yep. Did you have to write your own VM? Because I know there's a lot of performance only VMs out there.
Yeah, we run on different VMs. Yeah, they are. We do interesting things. Also, we make use of modern CPUs. In modern CPUs, you can parallelize things quite a bit. So we use SIMD, and if you are running QuestDB on Intel or AMD processors, we are parallelizing a lot of things, filters, and so on. So with one instruction, we are operating on several registers at the same time. If you are running on Raspberry Pi, for example, we are still not optimized. You can run it on our Raspberry Pi, but we are still not optimized for ARM processors. But for AMD and Intel, we do vector operations, we parallelize quite a bit. So yeah, we try to be as performant as possible.
Okay, that's good to know. I mean, I can't. I mean, I know you told me before it runs on Java, okay, which is why. But I wanted to let other people know, because it's quite amazing, right? You know, that people, it's so fast, you wouldn't necessarily automatically think that, but you've actually taken Java and you've tuned it to the max, right, to get this kind of performance.
Yeah, if it was written today, we might have chosen a different language. But the thing about Java at the time also, it was a matter of the ecosystem. We have a lot of tools for dealing with Java, and also portability. We wanted to run in as many like different systems as possible. And with Java, that's quite straightforward when compared to C or C++. Of course, today we might have gone with Rust if we were starting from scratch. We might. I'm not sure. But yeah, it was started when it was started. So yeah, it's Java all the way, and yeah, it's quite performant, I will say.
Yeah, sorry for derailing your demo. It was a question I thought that.
This is funny actually. So I wanted to show you. So we have like this, data set. This the symbol of the purchase, if it's like buy or sell, the price, and so on. So you could do interesting bits that are not straightforward on a relational database. For example, here, in a relational database, you can do a group by. Give me the average and the sum and whatever group by. But when you're working with time series, you don't want to group by very often. You can do it if you want, but very often you want to group by time. So I want to sample by, in this case, I want to sample in 15 minutes intervals. So basically what I'm doing is like I'm running some aggregation, but I'm not grouping by any columns. I'm just grouping by time. So in this case, I'm going to take all the data of this table from yesterday, and I'm going to run it in the aggregation in 15 minutes intervals, which is,
wow.
Yeah. And then you can do interesting bits. You can do interesting things. You can do things like, if I go down to 1 second, I told you in this table we get data more or less every second. Something interesting here is that you are going to see not in every second I have some data. And of course, this is a database. A database tells you only the data it has inside. But it could be super interesting if I could ask the database, when you don't have any data, I would like to know, because I want to identify gaps in my data ingestion. I want to identify if I'm tracking sensors from a machine or from a moving vehicle. I want to identify if at any interval of 10 minutes, for example, I'm not getting any data because maybe I have an issue there. On a database, I cannot see this. I mean, on a typical database, it can only tell me what it has inside. But something we can do in time series, in particular in QuestDB, we can say things like, oh, when you don't have any data for a particular interval, just do interpolation. In this case, I'm saying, I want to fill with the average from the row before and the row after. So now I have values for every second. Even if I don't have any data.
That's cool.
But I can also do a constant, So I can, for example, sorry.
Sorry, quick question. The sample size of 1 second, can you go down to millis if the data supports it?
We can go to microseconds as of today.
Oh, geez. Okay.
So microseconds, I believe, is the lowest resolution we support. In this data set, actually, we don't go that low. So you can see, but yeah, you can actually go down to, in the future, you will be able to go to nanoseconds. But as of today, we only go to microseconds because, for industrial, sometimes it's important. But you have different options for that. And of course, you can go for a day or for 1 year, for 1 month. So different aggregations that you can do. Nice. So in this case, I'm going to every second and I'm telling fill with null value, fill with null. So now I can actually see in which intervals I'm not getting any data. And now I could do something like, okay, with the sample queries, for example, sample Q as this, I want to find, give me all the rows where this column is null. So here, for example, I can see, okay, so tell me, sample Q, not sample D, sorry. So here what I'm doing is like, okay, first, get all the values, in 1 second intervals, fill with null, and now I filter only the null values. So I can see here, every interval of 1 second in which I was not getting data, or every interval of 4 seconds, which now it's much smaller, only 10 rows, or every interval, I have only 4 rows that's, that are, and I can see here, I don't have any gap of 10 seconds. So these kind of things are quite cool. And if you try to do this in your relational database, it can be done. I mean, I had to do this in Postgres a long time ago. It was interesting, but that's the thing. It can be done, but you have to start doing weird stuff like generating synthetic data for every second of the day and then doing an outer join between the other table and this one. It's kind of tricky. So these are like the things that you can do that are more or less interesting. If you want like crazy stuff, like the latest one I'm going to show you before I move to streaming, because I know we're not that great in time. But I told you before, we can do things like using this kind of syntax. So here I'm doing, give me how many trades I have at this particular second in October 28th, a week ago, in the two last, sorry, what happened here? Oh, here. So in the last 2 seconds of the day, so these are all the rows in the last 2 seconds of the day, but I can do more interesting things. Maybe I want to know what happened in the last 2 seconds of the day and the first 2 seconds of the next day. That might be interesting when a market is closing and opening, those kind of things. So I can do things like, okay, I'm going to go from this particular second and 4 seconds afterwards. So here I can see the 2 last seconds of this day and the first of the other. So this is like every individual record. But now I can do something like, okay, but I want to sample in 1 second interval. So this is better. It's like, okay, so this second, this other, this one. So you get the idea, yeah? 2 seconds before.
Have you, Javier, have you built yourself a micro trading app using this? Because the data is very, very handy.
We actually have a tutorial for that. Using the Coinbase, API, you can actually track prices. And when you see a trend, you can automatically buy or sell. So there is a tutorial on QuestDB for that, actually written. But
I'm just going to find that and share it.
For real, but we know some people that there are some traders that are ingesting every second of the day 100,000 records into QuestDB, and then like they're exposing that to their users. So it's used for this kind of things. And this syntax, like you can get crazy. In this case, I'm saying I want to have the 4 seconds after this particular thing, but I could do something like, and in intervals of 1 day, I want to get this for 7 days after this date. So basically now I'm exploring the last 4 seconds and first 2 seconds of the day for, the 7 days after. So you get the idea.
Wow. Yeah? What you're showing there is like, is this something that, as developers are coming to time series data and they want to learn of it, is this stuff specific to QuestDB, or is this generic SQL you're showing us?
This particular thing is specific to QuestDB. When we are talking about interpolating what I told you about finding missing data, that you can find in other databases. For example, TimeStream can do interpolations. Some other databases, they cannot do interpolations. Now there is a trend of databases that are generic and are adding a time series layer on top. Some of those cannot do interpolation, but most native time series databases can do interpolation. Basically, if you want to smooth a graph or something, it's quite interesting for that. But this kind of thing, this kind of range, I believe it's unique to us. This kind of thing.
That's really nice.
And the syntax look like it looks a bit scary, but it gives you a lot of power, with a concise syntax. So this kind of things is what we are about. So that's been for working with static data. Very quickly, I want just to show you how you can ingest streaming data. So in QuestDB, we offer we have client libraries in several languages: .NET, C and C++, Go, Rust, Python, Java, and JavaScript. So we have libraries. If we don't support your language, you can still send your data, but then you have to compose the data in a particular way. Comma separated, blank space, the timestamp in nanoseconds might be a bit tricky, but it can be done. We have on the website examples for sending data from Ruby or from PHP that we don't have official clients for that. But if you have the official client, I have here an example written in Go, which basically I'm going to send data to the instance, the Docker I started. I'm going to just start sending data. So I have this package in Go, the Go Quest client. I'm connecting to my instance I have on AWS. And I'm going to be starting, I'm going to send 1 million records in intervals of 1,000 records every 50 milliseconds with just random data. Just like, in a table called ILP test, I'm sending a device type, duration, latitude, longitude. It's just random data, okay? So if I send this data to my instance, right now, we are using the sender object. So this comes from the official client. I just pass the table name, the type of the columns, and I can start ingesting data. If I go now to my browser here, to this Docker we started before, we can see now we have a new table, ILP test. And if I query this table, it has now, let me for a second. Oh yeah, I know what's going on here. We have something we call the commit lag. Basically, when a table is new, we can keep the data in memory for a bit in order to be more performant. But actually, we can do something like, I want you to commit data every second. So now if I do a select count from the table, so we can see now in this, since I started, we ingested 700 and almost 750,000 rows, which is not
bad.
It's not too bad.
Not bad at all.
Yeah. So that's you could ingest faster. And by the way, I'm sending this from my local machine, and the instance on AWS is on Ireland, so there is also latency there. That's kind of the thing. And I have a delay of 50 milliseconds. And the latest thing I wanted to show you is that since we are compatible with Postgres, you can just use the ecosystem. For example, here I'm going to start a Grafana, just a Grafana container on the same machine. So here, if I go to this URL, but the Grafana port, I have an empty Grafana here. I configured before we started. I configured this to connect to my instance, but all I'm doing is connecting to the local host, the database, user and password, and that's it. We are connecting here, and I imported actually a dashboard in which I'm running some queries directly on top of this. We actually ingested the whole 1 million rows. So what I can do, I can start streaming again. So we are going to be ingesting new random data.
So what you're showing there, Javier, is this is Grafana, which is visualizing the data in your QuestDB, right?
Exactly. This is visualizing data. So it's telling me in the last minute we ingested 200,000 rows because I stopped it. But yeah, that's basically the idea. And this is just if I open any of these panels, it's just SQL. So just a SQL here using the Postgres connector. So that's that's kind of the idea. So yeah, that's you can integrate with many things on the ecosystem. You just SQL.
Yeah, nice. Very nice.
Sending a streaming
very
data.
Cool. Very cool.
You can stream if you want from Kafka. You can stream with we have a connector with for Apache Flink, or you can just use the client libraries. So that was basically what I wanted to show you. That was what I had for the demo today.
Yeah.
So yeah, any questions?
Well, thank you. We haven't had many questions on the chat, but for the next 5 minutes while we're on air, if you've got chat, if you've got any questions for Javier on time series databases, time series data, getting started, any other things that he shared, then now's your time before we close. I mean, it's a really nice demo. So thank you for doing that, Javier.
Oh, thank you.
I mean, it's an exciting area, right? Because I'm not that kind of like familiar with time series. I think last reInvent, me and you worked on that time series session for a reInvent, and it kind of opened my eyes to a lot of the things that you shared today, right? So thank you again for that. I hope people have found that interesting. We're now coming up to the last 4 minutes, so it's time to wrap up, Derek. I think we've got a transition for that, haven't we?
We do, I believe. It looks like this.
Okay, cool. Right. So we're gonna transition and close the show. So we've got 4 minutes. So we ran a raffle earlier on, and we actually have a winner. So as before, if you were paying attention,
oh, Derek,
which I hope you were. Yes, hope Derek. If you have received a code, and I'm gonna put it in the I'm going to put it in the chat. If you have the code with the first four blocks, can we actually show that on that? We can show this, can't we?
Yeah.
So if your ticket had those four, you have won. And what I want you to do now is contact us on Build on AWS with the last block of numbers, and that will confirm you've won. And then you have got yourself a very exclusive, signed, all things open poster from the event last week. So I hope you enjoy that. But yeah, tweet us, send us a direct message. Direct messages are open for Build on Open. So then you will win, and we will send that to you. Javier, thank you for playing the show. I believe you have received your coin.
Mythical.
Yes.
Thank you very much.
That's the first. That is a first for the show. Before we wrap up as well, just to remind people, there is an event section in the newsletter that's going to be published on Monday. If you want early access to that, then complete this survey. We ask you, I think, 5 or 6 questions. It'll take you 30 seconds, and you'll get the newsletter before everyone else. And specifically, a call out. The OpenSearch team, Chris from the OpenSearch team, got in contact with me yesterday. They're beginning a new weekly meeting from the OpenSearch team to triage and look at security. So if you're interested in seeing how open source works, if you're interested in security, or if you're interested in OpenSearch, then check out the newsletter, check out the details there, and come along because they're looking for people to join that conversation, that meeting. So with that, that's kind of like another episode of Build on Open Source. Join us again in 2 weeks. We've got the co-founder of Apache Hoodie joining us. So super excited about that. But with that, Javier, again, many thanks for your demo.
Have a good day.
Yeah, thank you everybody for watching.
And we're done.
Yeah, we'll see you in 2 weeks. Same time,
see you in 2
same
weeks,
place.
Hey there! Thanks for checking out this video. Remember to give it a like and share with your community. Then hit subscribe and the bell for all the latest content that will help you build on AWS.